At noon on Mercury's equator, the surface is 430 degrees Celsius. At midnight, that same spot drops to minus 180 degrees Celsius. The swing is 600 degrees on a single rock, with nothing in between. Most people know Mercury as the hot one. That framing is comforting. It is also completely wrong. The real horror of Mercury has almost nothing to do with heat. By the end of this video, the idea that Mercury is a dead, boring little rock next to the Sun is going to be permanently ruined. Mercury's numbers look simple on paper. A surface that scorches to 430 degrees Celsius at noon, then drops to minus 180 degrees Celsius by midnight. But the planet refuses to play by ordinary rules. While Earth spins once every 24 hours, Mercury's day stretches across 176 Earth days, long enough for a single sunrise to last nearly 3 weeks. This is no accident of cosmic laziness. Mercury is locked in a 3-to-2 spin orbit resonance, rotating 3 times for every 2 trips around the Sun. The result is a world where the definition of day and year are strangers, and the Sun's path across the sky is anything but predictable. Messenger's global thermometry mapped the full brutality. At perihelion, when Mercury swings closest to the Sun, solar energy at the surface jumps by a factor of 2.3 compared to its farthest point. The Sun itself swells in the sky from just under half a degree to nearly 3/4 of a degree, beaming down with a brightness that can bake metals and shatter rocks. Then, as the planet lurches away on its eccentric orbit, the furnace abruptly cools. Its eccentricity is 0.21, the highest among the major planets. No atmosphere stands guard. Heat radiates away into space, leaving the night side colder than any Antarctic winter, and the crust contracts so fast that rocks fracture in place. The day-night cycle isn't just long, it's real. At certain longitudes, the Sun appears to halt, then crawl backward for over a week before resuming its march. This apparent retrograde, a cosmic sleight of hand, comes courtesy of Mercury's odd orbital speed near perihelion overtaking its own spin. As a result, some unlucky patches of ground endure a sunrise, a pause, a sunset, and a second sunrise, all in a single day. This is not a planet that lets you settle into a routine. Thermal fatigue is relentless. Minerals on the sunlit side approach their melting points, fusing into glassy crusts. By night, those same surfaces contract, shattering into brittle dust. Over time, the ground itself is ground down, a slow-motion erosion powered by the planet's own inability to hold a steady temperature for more than a few months. The surface is always in flux, always on the edge between melting and freezing, never allowed to rest. Every familiar number, day length, temperature, distance from the Sun conceals a deeper instability. Mercury is not just hot, it is unstable, unpredictable, and caught in a perpetual contest between solar violence and cosmic cold. The so-called dead rock is, in reality, a world in constant upheaval, shaped by forces that never let up. And beneath these surface torments, stranger mysteries are waiting to be uncovered. Mercury's surface is a mask. Beneath it lies a planet dominated by metal, an iron core that makes up about 3/4 of the planet's total mass. That is a higher fraction than any other world in the solar system. The crust and mantle are little more than a thin shell, floating atop a heart of alloyed iron and nickel, possibly laced with sulfur and, according to a recent preprint, a 15 to 18 kilometers thick diamond layer at the core mantle boundary. If true, Mercury is the only planet with a diamond heart, a twist that would amuse any cosmic jeweler. This overgrown core is not just a curiosity, it is a source of hidden stress. As the core cools and contracts, it drags the surface inward, storing tension in the brittle crust. The planet is shrinking from the inside out, and the evidence is written across its face, scarps, ridges, and faults that slice through ancient terrain. But the core's influence is not limited to tectonic scars. It also powers a magnetic field, one that is both feeble and deeply off-kilter. Messenger's magnetometer measured a field that is only 1.1% as strong as Earth's. The planet's dipole is not centered. It is shifted 484 kilometers north of the planet's geometric center. This means Mercury's magnetic shield is lopsided. The southern hemisphere lies exposed to the full force of the solar wind, while the north enjoys a modest, uneven protection. The offset is not a minor technicality. It hints at a core dynamo that is either misshapen by compositional oddities or twisted by interior flows, perhaps even influenced by the proposed diamond shell. The result is a planet whose magnetic heartbeat is off-center, pulsing unevenly beneath the surface. For scientists, this asymmetry is both a puzzle and a warning. Theories multiply: a north-south difference in core composition, a skewed flow of molten metal, or a relic of ancient impacts. The truth remains elusive, but the consequences are clear. Mercury's weak offset field allows solar particles to carve and sputter the surface, driving chemical reactions and stripping away atoms. The planet is not just battered from without, it is leaking from within. Only a handful of machines have ever tried to measure these secrets. Mariner 10, in the mid-1970s, caught the first glimpse of a magnetic field where none was expected. Decades later, Messenger spent 4 years in orbit, mapping the field's eccentricities, charting the scarps, and tracing the planet's slow contraction. The next visitor, Bepi Colombo, is still en route, its sensors tuned for the faintest tremor or flicker in Mercury's magnetic shell. Each new dataset suggests more strain, more imbalance, more evidence that Mercury is a world under pressure, its iron heart cooling, its surface cracking, its shield failing in slow motion. Enterprise Roops slices across Mercury's battered southern hemisphere, a cliff that runs for nearly 1,000 kilometers and towers 3 kilometers above the surrounding plain. Its face is not the work of wind or water, but of a planet pulling itself inward. Mariner 10, swinging by in 1974, caught the first hints of these monstrous ridges, unexpected, even unsettling, on a world long dismissed as geologically dead. The spacecraft's grainy images revealed scarps that looked as if the crust had been shoved over itself, like a carpet bunching under invisible hands. But it would take Messenger, decades later, to map the full scale of Mercury's contraction. Messenger's laser altimeter swept the surface in precise, silent arcs, measuring heights to within a meter. The data revealed a network of scarps and ridges sprawled across the globe, all trending in ways that betray their origin. The planet is shrinking. Mercury's radius has dropped by about 7 kilometers since its formation. That is not a rounding error. For a world only 2,440 kilometers across, this is a catastrophic loss, enough to crumple the crust and force ancient terrain to ride up over itself in great, raw escarpments. The Great Valley, a trough more than 1,000 kilometers long and 3 kilometers deep, splits the surface like a planetary wound. These features are not scattered randomly. They form a global pattern, a record of relentless compression as the iron core cools and contracts. Each cliff, each thrust fault, is a scar left by the planet's struggle to fit its shrinking heart. Messenger's mosaics and altimetry transformed these cliffs from isolated curiosities into the signature of a world still in motion, still cracking, still settling, never truly at rest. In 2023, a team led by Mann and colleagues announced something that rewrote Mercury's reputation for good. High-resolution images from Messenger, once thought to be a closed book on the planet's tectonic story, revealed a set of narrow troughs called graben, cutting through older scarps near the Caloris Basin. These structures are not the ancient wrinkles of a planet that finished shrinking eons ago. They are fresh enough to stand apart, cleanly slicing through terrain battered by billions of years of impacts. Crater count dating, the planetary geologist's clock, tells the story. On Mercury, every new impact leaves a timestamp, and the absence of overlying craters on these graben means they formed after the last significant bombardment. Model ages land below 300 million years, yesterday in planetary terms. Some segments may be much younger still, their sharp edges and unweathered floors refusing to blend in with the planet's battered skin. This is not a world that froze solid and gave up its secrets long ago. The core is still cooling, still pulling the crust inward, and the surface is still cracking under the strain. The scars are not just relics, they are symptoms. Mercury is actively deforming, its skin splitting open to relieve the relentless pressure from within. In the universe's slow-motion horror show, this is the moment when the monster twitches again, just when everyone thought it was dead. The discovery unsettles more than just textbooks. If Mercury is still contracting, then its volatile rich surface is still being fractured and exposed, setting the stage for the odd, bright hollows and the planet's ongoing escape of material into space. The planet's story is not one of quiet decay, but of restless, ongoing violence, written in fractures less than 300 million years old. Mercury's sky is a masterclass in celestial mischief. Near perihelion, as the planet whips closest to the Sun, orbital speed overtakes its own spin. The Sun, already swollen to nearly 3/4 of a degree in the sky, hesitates. For about 8 Earth days, it slides backward, east to west, defying every habit of sunrise and sunset. At certain longitudes, a single Mercurian day can deliver a sunrise, a pause, a sunset, and then another sunrise, all before the calendar flips. This is not some rare eclipse or trick of atmosphere. It's the direct result of true anomaly dynamics, a planet outpacing its own rotation, caught in a gravitational loophole only orbital modelers could love. The ground beneath this sky is no less absurd. Despite the searing glare, there are places on Mercury that have never seen sunlight. Near both poles, deep craters carve out permanent night, shadows so deep and cold that temperatures never rise above -170 degrees Celsius. Here, MESSENGER's neutron spectrometer and Earth-based radar found bright, radar-reflective patches of ice. Not a dusting, but up to 1 billion tons, locked away in darkness. The ice likely arrived less than 150 million years ago, delivered by comets or asteroids, and has survived only because the sun's rays can't reach these crypts. The contradiction is almost theatrical. A planet famous for heat, yet hoarding frozen water in its shadows. A sky where the sun can't decide which way to move. The same world that bakes metals by day also shelters ice older than the mammoths. Mercury's extremes are not just about temperature, they are about the collapse of ordinary logic. Every new map, every radar ping widens the gap between what should be and what actually is. The closer science looks, the less Mercury seems to care about the rules. Mercury's surface is scarred by hollows, shallow, bright pits that seem to glow against the planet's battered crust. Some stretch up to 1.6 kilometers wide, but only sink a few dozen meters deep. They cluster inside craters, especially where volatile-rich minerals lie just beneath the surface. MASC's spectrometer data from MESSENGER revealed their distinct blue-tinged reflectance, pointing to freshly exposed sulfides and elemental sulfur. These are not ancient features. Their crisp edges and unweathered floors, paired with crater count dating, show they are less than 100,000 years old. Some may have formed in the last few thousand years, hinting at ongoing activity. The process behind these hollows is stark. When Mercury's intense sunlight strikes volatile-rich minerals, especially sulfur compounds, those elements sublimate directly into space. The ground collapses, leaving behind a pit and a halo of reflective dust. Some hollows appear to be venting material even now, as if the planet is still exhaling its lighter elements into the void. Beneath the surface, stranger possibilities emerge. In June 2024, Lin and colleagues proposed that Mercury might hide a diamond shell 15 to 18 kilometers thick, wrapped around its core mantle boundary. High-pressure carbon physics and seismic models suggest carbon could crystallize into diamond under Mercury's extreme interior conditions. If this hidden layer exists, it would act as a thermal blanket, slowing the core's cooling and subtly shaping the magnetic field. It might even help drive the migration of heat and volatiles upward, linking Mercury's restless surface to its mysterious heart. For geochemists, the idea is both thrilling and unsettling. Mercury, still evolving, still venting, still hiding secrets beneath its scars. A single scar still dominates Mercury's battered face. Scariest Basin, a 1,550 kilometers wide, wound, blasted open by an impact so violent it sent seismic shockwaves through the entire planet. The energy did not just gouge a hole, it ricocheted through Mercury's metallic interior and erupted on the far side. There, at the antipode, the crust shattered into the infamous weird terrain, a jumbled chaos of ridges and pits, as if the planet's skin had tried to crawl away from its own trauma. MESSENGER's imagery captures the aftermath, a landscape so fractured it defies any sense of order, the lines of force from the impact still visible in the ground's geometry. But the violence did not stay locked in the rock. Each new impact, each solar wind gust, chips away at Mercury's surface, releasing a steady stream of atoms into space. Sodium, in particular, escapes in such volume that it forms a tail stretching up to 24 million kilometers behind the planet, a structure so vast it dwarfs Mercury itself, trailing like a ghostly veil across interplanetary space. The sodium tail glows brightest at 589 nanometers, a spectral fingerprint captured not just by spacecraft, but by amateur astronomers on Earth, who track its shifting length and brightness as Mercury swings around the Sun. This is not a static world. Every tremor, every impact, every burst of solar wind is met with a planetary exhale. The sodium tail is Mercury's ongoing loss, a visible sign that the planet is bleeding off its own surface, atom by atom, orbit after orbit. The same physics that carved the weird terrain now drives material into the void, connecting geology to space in a continuous, uneasy exchange. Even from millions of kilometers away, Mercury's suffering leaves a stain, a luminous trail that marks its passage and its pain. Long-term computer simulations of Mercury's orbit read like a cosmic lottery ticket with stakes no planet should face. In 2009, Jacques Lascar and Michael Gastineau ran 2,501 slightly different versions of the solar system, each nudged by less than a meter in Mercury's starting position. In 20 of those universes, about 1%, Mercury's orbit slipped into chaos. Sometimes the planet collided with Venus, sometimes it spiraled into the Sun, sometimes it was thrown clear of the solar system altogether. The difference between survival and catastrophe can hinge on a rounding error in the initial conditions, yet most of the time, Mercury's orbit holds steady. The reason is a subtle correction from Einstein's theory of general relativity. Mercury's perihelion, the point in its orbit closest to the Sun, advances by 43 arc-seconds per century, a slow, relentless drift that keeps the planet's 3-to-2 resonance locked and steers it away from the worst gravitational traps. Without this relativistic nudge, the odds of disaster leap above 60%. With it, the solar system's clockwork persists, but only just. Against this backdrop of cosmic Russian roulette, humanity prepares its next move. Bepi Colombo, a joint mission from ESA and JAXA, is closing in on Mercury, scheduled to break into orbit in November 2026. Its payload is a catalogue of curiosity and dread, with altimeters to measure whether Mercury is still shrinking, spectrometers to catch the faintest whiff of volatile escape, magnetometers to probe the lopsided field, and high-resolution images to watch for new hollows forming in real time. The mission will test whether the planet's diamond heart is real, whether the polar ice is being replenished, and whether the crust is still cracking under the pressure of a cooling core. For now, every number, every orbital parameter, every magnetic anomaly, every fresh pit in the crust serves as a reminder. Mercury's future is not guaranteed. Its fate is balanced between the deterministic equations of physics and the unpredictable churn of chaos. As Bepi Colombo draws near, the planet waits, still shrinking, still venting, still playing its improbable hand against the universe. Out here, the universe plays dice with orbits. Mercury's crust buckles as its core shrinks, bleeding atoms into space and daring chaos with every circuit. Astronomers calculate a non-zero chance, about 1 in 100, that Mercury's path unravels entirely in the far future. For now, the smallest planet remains a trembling edge case, reminding us even the most familiar worlds are only ever provisionally stable. Thanks for watching.